Hi everyone, this lesson is for geometry students. This is chapter 5, day 3. Lessons are on special right triangles and the Pythagorean triplets. So let's get started. Warm up. We're going to start with a warm up, and this is a 10-foot ladder that leans up against a wall. And the angle that it makes with the ground is 64 degrees. So there's a 64 right here. The question is, how far up the wall does the ladder reach? And so you actually have two options for this problem. In order to use this, you're going to use sine, cosine, or tangent. But because you have actually two sides, we have option A is to use sine. So I can say sine of 64 degrees is equal to, I have the opposite side, and I have the hypotenuse, which is 10. So I can say sine of 64 degrees is equal to x over 10. The other option is to say, well, I also have the adjacent side. And so I can say tangent of 64 degrees is equal to opposite over adjacent, which is x over 5. So x over 5. And then just a note, lastly, they're only asking me for the height right here, which if I have this side here and I have this side here, I have two sides of a right triangle. So my third option is to just use Pythagorean theorem, which is just x squared plus 5 squared is equal to 10 squared. So if I were to simplify this, I get 10 squared, I get plus 25 is equal to 100. I get x squared is equal to 75. And then x is equal to the square root of 75. And I would use this if they were asking me for an exact value, because an exact value for root 75, I could say, well, that's root 25 times root 3. And root 25, so that would be 5 root 3, which gives me an estimate, 5 square root of 3, of about 8.7. So this gives me about 8.7. So I have an option if they say to put my answer in decimal value, I'd say 8.7. Put my answer in exact value, I'd say 5 root 3. Simplifying one of these ways, I would just cross multiply. And I would say, if choosing this one, I'd say x times 1, which is just x, is equal, and that's the 1 under here, is equal to 10 times sine of 64. And then because you will be rounding off. This is not going to give you an exact value. This is going to give you an approximation. So sine of 64 equals like 0.898. And if I multiply by 10, I get 8.9 right around there. So because we rounded off, we're not getting the same value as if I were doing an exact value, but it's pretty darn close. So today's learning targets, we're going to talk about similarity and ratios of 30, 60, 90 right triangles and 45, 45, 90s. Also, students are going to be practicing recognizing and applying shortcuts to the Pythagorean triples. Okay, so you do need to know how to rationalize a denominator, and exactly what does that mean? It means that you're not going to leave a root on the denominator. So that means we're going to be multiplying by, in order to rationalize the denominator, we're going to multiply by whatever root is on the denominator, which is root 2. But remember, you can't change the problem. So it is okay to multiply by 1 in the form of root 2 over root 2. So I would end up getting 6 root 2, because numbers get multiplied with numbers. Roots get multiplied with roots. So root 2 times root 2 is root 4, which is 2. These are going to cancel, and my answer would be 3 root 2. For this problem here, you always can divide roots with roots. So this is actually saying the square root of 12 over the square root of 10, but you can cancel out roots with roots. So you just can't cancel out numbers with roots. So root 12 and divided by 10, I'm going to divide by 2. I'm going to get 6 over 5, which brings us down to root 6 over root 5. And again, I have a root on the denominator. I need to rationalize the denominator by multiplying by 1 in the form of whatever the root is, and the root is root 5. So I'm going to have the square root of 30 over the square root of 25, which is 5. And so that would be my answer. Remember, numbers can't cancel with roots, but for example, if I had had root 30 over root 5, then my answer would be root 6. Okay, So one of the questions that I'm going to ask you is what happens when you reflect this triangle, meaning across an axis, like this being my axis right here? What happens if I reflect that across, right? I would actually get this, that something that looks like this. All right. And so in doing that, when you're trying to reflect something across, what that does is it makes the sides actually the same, like equal. That would then be equal to this side here. Additionally, this right here is a 30, 60, 90 right triangle because I already have a value of 60. It's a 30, 60, 90 right triangle, but the whole triangle, if I were to reflect it, then became a isosceles triangle. That became an isosceles triangle. In order to solve the triangle, they're looking for values of A and B. Well, across from the 90, remember the shortcut, across from the 90 is equal to 2A, which means A equals 1. So that means across from the 30 degrees is 1. Across from the 90 is 2A, we know that's 2. And then across from the 60 is going to be A root 3. Well, if we know A is 1, that's going to be 1 root 3. So for the next problem, we want to find the missing lengths. So again, we're going to use all the little tricks as far as as far as opposite the 30. So if opposite the 30 degrees is A, then opposite the 90 is twice that. So that would be 30. Opposite then the 60 is going to be A root 3, or 15 root 3. Okay. Opposite the 90 is equal to 2A, which means A is equal to 4. A would be across from the 30, so that means Y equals 4. And then this being 60 degrees, opposite the 60 degrees, we have A root 3, which then means X is equal to 4 root 3. Is this a 30, 60, 90 right triangle? What you should notice is that what makes a right triangle 30, 60, 90 is if I had a 30, 60, 90 right triangle, and let's say A was 5. Across from the 90 would 2 times that, and across from the 60 is 5 root 3, or A root 3. But if my hypotenuse, which is 10, is opposite the 30, right, which is 5, that means that this is twice whatever is opposite the 30. So if this being the smaller side is 30, then opposite that 30 is our A. And then opposite the 90, that would be 2A. So if A is 3, this would be 2 times 3, which is 6, not 7, which means no, this is not a right triangle because whatever my hypotenuse is, it has to be double whatever is across from my 30 degrees. Solving these triangles here, these are 45, 45, 90s. And the rule for a 45, 45, 90 is whatever the value of is 1. So if I had a 45, 45, 90, let's review the rule. In a 45, 45, 90 right triangle, here's my right triangle, that's 45, 45, 90. It's equal, 45, 45. This is X, and whatever this is going to be X root 2. So if this is 1, this is 1, and this is 1 root 2. And we don't need to put the 1 above that. So again, both of the angles have to be the same, which means both of my sides are the same. So if that's 20, this is 20, and then this is going to be 20 root 2. Across from the 45, these are going to equal, because that's also 45. So we have 5, 5, 5 root 2. Well, again, X root 2. See how 8 is 8 root 2? I can set 8 root 2 equal to X root 2, and that gives me X is equal to 8, which means each of my sides is 8. 45, 45, 90, again, X, this becomes X root 2. So if my sides are 3, this is 3, 3, and so this side would be 3 root 2. X root 2. That's our little formula. So this one's a little bit tricky because this is 4 root 2 is my X. And you know these are the same, so that's also 4 root 2. So X root 2, so there's my root 2. X being 4 root 2, so I have 4 root 2, which means root 2 times root 2 is 2. So 4 times 2 is 8. Now, just a note, going backwards, so like if I had this angle in the front in the beginning, which was 8, and I wanted to go backwards and figure out what the side was if this was a 45, 45, 90. The rule is to divide by 2 and multiply by root 2. So that means I would take my 8, divide by 2, I get 4, and then I'm left with root 2, which is what our side value is. More ratios. If y is across from the 30, that means across from the 90 would be twice that. And if y is across from the 30, then this would be y and then root 3. So what we're doing is we're looking for patterns here. Across from the 90 is 2a. So across from the 90 is 2a. That means a, which is across from the 30, is going to be x over 2. So that's my a. So then that means if across from the 60 is a root 3 and a is x over 2, then across from the 60 is going to be x over 2 root 3. Now, this right here is a 3, 4, 5 triple. So this would be 3x, 4x, and this would be, not 4x, sorry. This would be 3x, 4x, and then 5x. And then likewise, another triple, 5x, 12x, and 5, 12, and let's see here, 144. So what's 144 and 25? 9, 6, 1. So that's 169, which is a 13, right? 5, 12, 13. And then x, x, and then x. And that's where that came from. For this one here, this is, looks like, I'm assuming this is going to be a square. They didn't say that. It's either square or rectangle. But this would be 2 root 2. This would be 2 root 2. And this side would be 2 root 2 root 2. So 2 times 2 is 4, so x is 4. This is another triple, 8, 15, and then this is 17. And the way I would find that, if I didn't know that, if I didn't remember that, is I would use Pythagorean theorem again, and I get 64 plus 225 is equal to z squared, and 225 is what I said, but I didn't write it. And so 225 plus 64, right, is 289. So 289 is equal to z squared. So z is equal to the square root of 289, and the square root of 289 is 17. Find all the lengths of the sides of the triangle. So for this one right here, we have 12. I know this is a 45, 45, 90 because my angles are the same, which means if my angles are the same, the sides have to be the same. So this is 12, 12, and then this is going to be 12 root 2. And again, another 45, 45, 90, x, x, so x, x, and this is equal to x root 2. Now, remember, if you forgot the formula that said take that hypotenuse and divide by 2 and multiply by root 2, which gives me x equal to 4 root 2. If you forgot that, you have options. Option A is to use the Pythagorean theorem, which is just x squared plus x squared, because they're the same value, it's 45, 45, 90, is equal to 8 squared. So 2x squared equals 64, x squared equals 32, and x is equal to the square root of 32, which is the square root of 16 times the square root of 2, which is 4 root 2. Again, other option is to take 8 and set it equal to x root 2, in which case we'd rationalize the denominator after I divided both sides by root 2. So x equals 8 divided by root 2. I would need to multiply by root 2 over root 2. So I have 8 root 2 over 2, which is going to be 4 root 2. So again, lots of options for solving the 45, 45, 90s. Again, without a calculator, meaning don't use sine, cosine, or tangent, try to come up with the rules for this. So across from the 30 is a. Across from the 90 is twice a, so that's 10, so that's going to be 20. And then across from the 60 is going to be a root 3, or 10 root 3. Same thing. Now this one's a little bit different, because across from the 60 is a root 3, right? Which means that I have to use my little formula, which says divide by 3 and multiply by root 3. So I'm going to take 9, divide by 3, so that's going to be 3 root 3, and that's my a value. So across from the 30 is 3 root 3. Across from the 90 is twice what's across from the 30. So that's 3 and 3 is 6. So that's going to be 6 root 3. And then I have x root 2. So x root 2, remember. So I could either divide by root 2 or I could use my formula which says take 6, divide by 2, and multiply by root 2, which means that the side lengths are 3 root 2. Both of the side lengths are the same. Opposite the 90 is equal to 2a. A is across from the 30. So then if a is equal to 3, across from the 30 is 3. Across from the 60 is going to be a, which is 3, and then root 3. So without a calculator, what you're doing is you're allowing yourself to get what's called an exact value. Okay? And an exact value is not a decimal equivalent. I can absolutely take this same triangle that I just did right here with the 60 and the 30 and put myself right here, okay? There I am. And what do I know? I know that the hypotenuse is 6, and if I wanted to find this side, I could use sine. So sine of 60 equals x over 6. And then I would cross multiply. I get x, or 6 times sine of 60 is equal to x, and I'd solve for that value, and I would be able to find, whatever side I'm looking for. Just keep note that if it says without a calculator, they're expecting you to get what we call an exact value. Again, not a decimal. Now this one is just saying, hey, find the height of the trapezoid. This looks like it's an isosceles trapezoid, which means that this length here has to be the same length as this. So if I were to take 22 and subtract 8, that means that, because this whole length is 22, and if I subtracted the top part, which is 8, this little part right here, I get 14, which means this length on the left is 7. All right. Now that being 7, to find the height, I can just use Pythagorean theorem, like 7 squared plus the height squared, side squared plus side squared equals 10 squared. So height squared is equal to 100 minus 49. So my height is the square root of, my height is the square root of 100 minus 49, and I get about 7.14. So h is about 7.14. And so they're asking me just for the height of the trapezoid, and they're asking me for the height of the triangle, which is y. This triangle is equilateral. That means that all 3 sides are congruent. It also means that this height cut my base down here into 2 equal parts. So if this is 6, these are 3s. Now again, equilateral triangles have all angles of 60 degrees. So that's 60, and this whole thing's 60, which means since it's cut in half, that's 30. Across from the 30 degrees is my A, that's 3. Across from the 90 is twice that, which is 6, which we already knew that, because in an equilateral triangle, all the sides are the same. And then lastly, across from the 60 is A root 3, or 3 root 3. So that means y is equal to 3 root 3. For this problem, again, 60 degrees, this is a 30, 60, 30, 90. Across from the 60 equals A root 3. I can either solve for this A, and I get 9 over root 3, for which I have a root on the denominator. I need to rationalize the denominator, so multiply that by 1. By whatever the denominator is, I'm multiplying by that in this problem. So I get 9 root 3 over root 3 times root 3 is root 9, which is 3. Cancel those, I get 3 root 3. So A is equal to 3 root 3. And what that means is across from the 30 is 3 root 3. And then across from the 90 is twice that, so that's going to be 6 root 3. This is a rhombus, because 2 sides that are consecutive and my diagonals that are congruent, that makes a rhombus. So what this does here is, first of all, in a rhombus, if you recall, that the angles are bisected. So that means, and their opposite angles are the same. So those have to be 30s. Additionally, that's 60. So I've got a 30, 60, 90, which means, and in a rhombus, all the sides are the same value. So those are all 6s. So across from the 90 is what we call 2a, right? So 2a, so that means a is equal to 3. So across from the 30 is a, and across from the 30 is a, which is 3 root 3. So the question says, find all the sides and the angles. We did. I would also behoove you to find each of the diagonals. So diagonal 1 and diagonal 2. So for this problem, the first diagonal is 3 plus 3, which is 6. The second diagonal is 3 root 3 plus 3 root 3, which would be 6 root 3. For this problem, to find the area in the perimeter, we just did something, I think, very, very similar to this, where this would be 6. And let's see, I know that's 60, so this must be 30. Across from the 90 is equal to 2a, which means a is equal to 3. So this is 3, which means that's 3. Additionally, let's see here. These are equal, so that's 6. So this length is, what is this length? This length is 6. This length is 6. We also know all the singletons are the same value, so that has to be 6. And that's 6. So that's equilateral. And let's see, what can we do here? I guess if these are equal, those are also 6, because it says that these are the equal lengths, so that's also 6. So to find the perimeter, I'm just going to add all the values around. So I have 6 plus, I got 1, 2, 3, 4, 5 6s. So to find the perimeter, that's going to be 6 times 5, which is 30 units. To find the area, though, that's a little bit different. And because I have to come up with a plan, meaning my plan is to find the area of the triangle plus the area of the square. That looks like it's a square, even though it doesn't look like it's a square, it's a square. So 6 times 6, which is 36. So this is 36 units squared. And then to find the area of this triangle, it's 1/2 base times height. So I don't know my height, although I do know it, because if this is a 30, 60, 90 right triangle, across from the A is 3. That means across from the 60 is A root 3, or 3 root 3. So when I'm trying to find the height, I'm going to go 1/2 base, which is 6, times my height, which is 3 root 3. So 2 divides into 6 3 times. 3 times 3 is 9. I have 9 root 3 plus 36. So my area is going to be 9 root 3 plus 36. And as a quantity, that's units squared. Now, if you wanted an approximation of that, you would go on your calculator, find a value of 9 root 3. So I'd go root 3 times 9, and I get 15.6. And this is going to be 15.6 add 36. So add 36, and I get 51.6. So this is about 51.6 units squared. And that's the same problem. And for this problem here, you would need to find the error. So they're talking about Pete made a mistake somewhere. There's theta, and cosine is adjacent over hypotenuse, which is 2.736. And apparently, when you use cosine of theta and you go 8 over 2.736, because, right, to find theta, you're going to go theta equals arc cosine of 8 over 2.736. And so theta is approximately going to be, let's see what that comes out to be, 8 divided by 2.7. So let's quit this, whatever I was doing there. And I'm going to go arc cosine of, what was my values? 8 divided by 2.736. So 8 divided by 2.736 equals, and I'm going to get an error. So the problem is what's the error? Why am I getting an error when I do this that I know we have to do? Well, what you should have seen, and hopefully you did see this, is that the hypotenuse, right, for sure has to be greater than both of the lengths of the sides. The hypotenuse is always going to be the greatest length. And so if your hypotenuse, for whatever reason, is less than either either of the legs, then the problem is you're not going to be able to do the problem. At this point, your toolkit should include your Pythagorean theorem, tangents, sines, cosines, inverse functions, special right triangles, and Pythagorean triples. So let's remind ourselves what those Pythagorean triples are. And those are our 3, 4, 5s, which we discussed. They are our 5, 12, and 13. They are 8, 15, and 17, and then 7, 24, and 25. So these are all the triples that you should have at this point in your toolkit. And then, yes, you can have a variation of some of these. Like, for example, if I had a 3, 4, 5 and I multiplied by 2, I would have a 6, 8, 10. And this might be familiar to some of you who are used to seeing, you also might have seen this one, which is 10, 24, and 26. That's this value here times 2. So you could see multiples of this. If I were to take 3, 4, 5 and multiply by 3, I would get 9, 12, and 15. And so some of you might see something like that that's familiar. Those are our Pythagorean triples, or these are multiples of triples, but the actual triples are just those 4 values. So this is your toolkit. This is in their packet that you received, as well as it's online in your textbook. Your learning targets, 30, 60, 90 right triangles. Also talk about Pythagorean triples, which we did. Your homework is a Canvas quiz that we're going to be taking Thursday and Friday, which is not Monday and Tuesday. So that did get extended to Thursday and Friday. So this right here, that's going to be Thursday, not Monday and Tuesday, but Thursday and Friday. And then this is your homework right here, along with the homework from the Pythagorean triples. All right, which is L5.2.2. So you're going to be doing both of these tonight. Keep in mind that you still have the Canvas practice quiz, which goes along with the actual, it goes along with a video that is already posted on your slate. So thanks so much for watching, and I'll see you in class.